Well, good afternoon and welcome to today's podcast on end-to-end innovation. I'd like to welcome everyone and welcome our guest, Ron Mayfield, a distinguished enterprise architect at Oracle. Really great to have you on. Ron, thanks for coming.
Thank you for inviting me. I consider it an honor.
Oops, sorry, 1 second. Let me make sure I turn this off. All right. So again, thanks for coming. So today, we've got a couple of topics. In the announcement, I mentioned we're going to talk about just what is enterprise architecture in general. And Ron, as you'll soon learn, is one of the more experienced enterprise architects on the planet, and so can bring a lot of wisdom to the table. And we're then going to seg into a specific topic that enterprise architects deal with today, which is how to make choices around which database to use or which data store. And so Ron, in his efforts to help Oracle customers understand how to make good decisions around the database, has come up with a model called ICAM. So we're going to spend quite a bit of time digging into that. And that fits into our kind of overall general interest in decision-making. How do you make good decisions to innovate in not only IT, but really beyond as well. So with that, again, I will seg into here. So again, thank you very much for joining, Ron. Ron, can you tell us a little bit about yourself? I know you've been at Oracle for quite a while. That's where your career started. Can you walk us a little bit through your career and help the audience understand how somebody like you, how an enterprise architect gestates and turns into somebody who can help people make the best decisions possible?
Yeah, my first career was a musician. I was a classically trained musician. And that's actually very good. You'll see a lot of IT people have musical backgrounds because when you look at and study and perform very large symphonies, which is what I specialized in, you get this understanding of what the big picture is, what form is within music. And a lot of those skills I use in enterprise architecture. So my wife was also a musician. We decided one musician in the family was enough. So I went back and got an MBA MIS from the University of Houston. And I got a really good education there. And I'm going to call out to my professor, Dr. Scammell. I had 2 semesters of database design at the master's level there. Just a phenomenal class, phenomenal knowledge. So I came out of college very knowledgeable about relational databases.
Wow.
Yeah.
Where did you go to college again? Sorry?
University of Houston.
Okay, very good. And now what instrument do you and your wife play?
So I played trombone, but I also studied conducting, which is where I did all the analysis on these very large symphonies. And I learned all about form. My wife is a flautist, and she also plays piano and organ. She's one of those multi-talented people, which is why she's still a musician, and I went into IT.
Okay. Very cool.
So after my MBA, I got a position at Arthur Andersen Consulting, which now, of course, is Accenture. I was there for almost 3 years, and then I jumped over to Oracle. I've been at Oracle for 33 years now. So I started in consulting, doing hands-on development. I worked my way up from a basic coder all the way to a project manager and principal consultant, an architect. From there, I jumped over to internal development, where I worked on oil and gas applications, specifically exploration and production systems. And then from there, I went to several other pre-sales jobs where I was the technical arm of the sales team at Oracle. Mm-hmm. So I actually saw Oracle back in college. It was version 4 of the Oracle database. And then on my first project, when I got to Oracle, it was version 5.
Okay.
So I've seen the Oracle database grow up to become the very large enterprise quality database that it is today. I've worked with a lot of customers. I probably worked with well over 250 customers in my career, everything from very small municipalities to Fortune 10 companies. I've been very blessed by having that amount of different customers.
Yeah, and I think it's something enterprise architects and vendors do have, who have like in your case, have a long tenure. You get to see many different customers, and that really can help build up the experience, and sort of you can pattern match, you can see trends.
Yeah, all those skills I learned when I was analyzing Mahler symphonies, I can use in analyzing very complex systems like what you see on the screen here as an example. And but most importantly, I started off as a programmer. And when I was in consulting, I got to do full life cycle. I got to be on projects where we started with, okay, end user, what do you need? And followed all the way through to post-production support. And for an enterprise architect, I think that's very important that you have that skill set. So I use the analogy because I'm one of the leads in our EA master class, training classes. So in the class, I use this analogy that a good EA should be like a chess player. So a decent chess player is 2 to 3 moves ahead of where they are on the board, but a grand master can be 10 to 12 moves ahead of where they are on the board. So an enterprise architect, if you have full life cycle experience, you may be very early on in making design decisions, but if you know what the ramifications of those decisions are all the way down into the build and into the production support, part of the life cycle of the application, you become much, much more valuable. I can help customers make good decisions early on so that they don't make mistakes later on the life cycle, which can be very expensive.
And I think that, you've had that repeated experience. I was talking to another senior IT expert that I had on last week. And again, he's similar. He was more from the customer side, so more from the customer, the end user side, and was able to basically, build many systems over many long periods of time.
Mm-hmm.
And again, that just builds up a deep level of experience that I think is.
Yeah, so I wrote a white paper on LinkedIn on defining IT architecture disciplines. So my experience has shown me that there's 4 different architecture disciplines. There's the enterprise there's actually a 5th one, more of a business architect, but within IT, there's 4 architecture disciplines, which is an enterprise architect, an application architect, an information architect, and an infrastructure architect. So there's a lot of people out there who call themselves enterprise architects, but they're more like an infrastructure architect or an application architect. It's the enterprise architect that has that experience, that 20, 30 years experience, broad knowledge across application, information, infrastructure, that can truly be an enterprise architect.
So what do you see today? I mean, do you see a balance where, people who have that end-to-end experience, like you said, that sort of enterprise, I sometimes I call it system thinking, where you have a deep understanding of applications, databases, different types of information, infrastructure. You really have that big picture. I think people like this are fairly uncommon, but I don't know. Correct me. What do you think? I mean, how are customers in general doing at this? Are they thinking like this way, or is it a tug of war between the app developers and infrastructure and security, et cetera?
Oh, I didn't include that slide. I actually have a slide, which I've been writing on the whiteboard for a long time, so I put it on a slide where most customer I interact with have this triumvirate, where if you think of a triangle, on one corner of a triangle are the enterprise architects, on another triangle are the development team, and the other point of the triangle are the infrastructure team. Yeah. So whenever I start working with a customer, I try and figure out what are the dynamics between those 3 teams.
Okay.
Yeah, a lot of the enterprise architects who don't always add a lot of value, they're more like glass house. They do standards and write a bunch of diagrams, and then they try and enforce those standards, and the development team's going, no, we're going to use this, and the infrastructure team says, no, we've standardized on this, and this is what, and you don't get a lot of governance and control, those checks and balances that you need. And to be honest, most enterprise architects that I run across are really infrastructure architects. They've come up through the infrastructure, and that's what they focus on is getting the infrastructure correct. And the type of architects I see the least are information architects. That is probably one of the most difficult things to do, because if you're coding, you're hands-on. You can see the code. You can, run it and see if it works or not. If you're an infrastructure guy, I mean, you got a storage server. You got something there. An information architect, the information is all conceptual.
Yeah,
it's a little more difficult to get your hands around concepts like how do we increase the value of information, which is one of the things that information architecture should really be focusing on. How do I increase the information of my organization? or increase the value of the information in my organization.
Well, it's interesting that you say that, because if I look at all the people that are that I've had on my podcast, almost all of them, with one exception, are infrastructure. To your point, the one exception was a machine learning fellow, very, very prominent machine learning, big data kind of guy, who was a CTO at a cloud analytics startup. And so he was the information architect. So yeah, that's very noticeable. I think there's a crucible that infrastructure people have to go through, because they really do have to deliver. I mean, it's if their stuff doesn't work, the place shuts down. So there's a sort of a certain floor of competence, and then they're also like I have a close friend of mine who works as a CTO level guy at United Health, and he was really a storage infrastructure person, but then he had to make sure that everything worked, server storage, et cetera, for applications. So he built up that systems expertise you just described. And then they promoted him to distinguished engineer there. So that's very noticeable, isn't it? It's very interesting.
It is. And I was in operations when I first started off, way back in college. And I got to tell you, that's a tough job. In operations, if nobody's yelling and screaming, that means you're doing a good job.
That's right.
Seriously. And change is risk. So status quo, if it works, don't fix it, is kind of the mentality. Whereas developers are driven by change. They're driven by, we got to go code something, we need to improve, and we have budgets and we have deadlines, so we got to go fast. So faster change, the better. Yeah. And then you have the architecture team, which is driven by what's our 3-year roadmap and how do we align with the business. So in those 3 organizations, you'll see a lot of conflicts because they're motivated and driven by different metrics, and the dynamics between them can be quite interesting because of that.
So what are you seeing today? Are you seeing which of these tends to dominate in terms of decisions? Is there one that tends to, you've got application, infrastructure, information, and then the overlay, kind of like people like you that see the big picture? Who tends to dominate?
So it really depends on the organization and the culture of the organization.
Okay.
So in the past, it was actually the people who had the highest IT budget were the storage team. So they had a lot of power. But with cloud becoming prevalent, that on-site infrastructure team is losing their power, and now the developers, under the guise of you got to be agile, are becoming more and more powerful in the decision-making processes in our organizations. Because let's real quickly, let's talk about cloud. What is cloud? Cloud is the automation of IT. And for the last 40 years, we've been automating other people's business processes, but cloud is really, once you get infrastructure set up, it's 5 clicks in our cloud, and you've got an Oracle database.
Yeah,
completely automated. So a lot of that whole infrastructure, the power that those people had is going away. It's becoming automated away, which I think is a very interesting dynamic too in itself.
Yeah, that's something I've noticed with customers. But for customers, for example, still building their own internal clouds, you still need really good infrastructure people.
Oh yeah.
To understand how all the cloud, how that cloud technology works. What about application teams and these application architects? Do they have a systems viewpoint, or what's your general, and I know it's a very broad question and it's a very broad audience, but what do you see trends there?
Oh, you're going to have me say some very politically incorrect things. In information architects, because I'm an enterprise architect, but my specialty is information architectures. So the developers, again, under the guise of agile, have gone toward, and from the perspective of a developer, I want to make life as simple as possible. And so you look at the Agile Manifesto, number 7, what is number 7 says, the measure of success is how much working code we create. It doesn't say anything about information, data structures, or how well they meet the business. It's all about how much code can we create. So from a developer's perspective, I want to limit outside influence that's going to slow me down so I can make my time budget constraints. So they do a lot of things like go to microservices, and some people are saying, let's decompose that monolithic database, and we'll do every microservice has its own data store. Okay, as an information architect, I think that's completely nuts. Because every CTO I've talked to, I usually hear them say two words: simplify and consolidate. So if you take a database, one relational database, and now you've decomposed it into 5 different databases, which may be different technologies, have different security models, have different backup and recovery. Now you're doing, instead of doing SQL calls and joins, you're doing interfaces, API calls between them. The whole environment just gets a lot more complex. Now, from that developer perspective, oh yeah, I have my own microservice, I have my own data store, my life is wonderful, I don't have any outside influences, so I can be agile. But looking at the big picture, that does not meet the goals of simplify and consolidate. It actually makes things much more complex.
Yeah.
So those are the pluses and minus trade-offs. But I'm seeing a lot of IT organizations now that are going toward agile and modernize and cloud native, and they can get themselves into trouble with the complexity pretty quickly, increasing complexity. So as an information architect, I want to make sure that I know where my data is, that my data is secure, that it's available. I want to make that as simple as possible, but I also want to be able to extract value out of that information. So instead of just that data being within an application, I'm going to be looking at what I call the information value lifecycle, which is, okay, I have transactional data, it lives in this application. Does that data have value outside of that application? Does somebody up in the food chain of the organization need access to some of that data so they can make a better decision? If so, then that application should not own that data, should not be the sole controller of that data. That data has value outside of the application. So that's when the information architect should get involved and have some governance over what that information is, what it looks like, what its structure is, so that it can be used in other parts of the organization. Make sense?
Yeah, and I mean, think about what when Cod first came out with the relational model. That's really literally the first thing he said in his paper is that we need a model of the data that's not embedded in code, and that's really what the core idea is. And then to your point, it's data reuse, and I think, I don't want to, that's been. I don't want to get too deep in the weeds of a specific technology, but it's very clearly been a sort of a swing from information architects and data owners to developers and applications. So that sort of drives everything, or tends to overwhelm everything. And then downstream from that, you don't have data models that are comprehensive and uniform. And to your point, you don't allow for organizational reuse to really drive business outcomes.
Yeah, and that causes organizations a lot of problems because the agility of an organization, not of a developer, of an organization is what's important. So here's the 4 rights: getting the right information to the right person in the right format at the right time, so the best decision can be made at any point in time.
Yeah.
That's what defines an agile organization. So let's decompose that. The right information. So you have to know where the information is, where it resides, and you also have to put on top of that a layer of security so that you don't have somebody having access to data that they shouldn't have access to. So the right information has many dimensions associated. To the right person. So that again has security involved in it. It also has, how do you get that information from like a transaction system to another system like a data mart or data warehouse, so that the right people, the right personas can have access to it. Now in the right format. So if the data is not presented in the right format, it cannot be easily consumed.
Yeah.
So that points to summarization, aggregation, and when you get all the way to predictive analytics, that machine learning, being able to apply machine learning to that data to make more sense out of it, make better decisions.
Yeah.
Okay. And then at the right time, as we're going to see here in a little bit, the time value of information drives more architecture decisions than any characteristic of information, I believe.
Yeah.
So the time value. So Does somebody need the data? We're doing quarterly reports, so the data can be 3 months old and it's still value.
Yeah.
Or are we making real-time decisions? So I work a lot in oil and gas. And it's very important if you're drilling a well that you have real-time data, because if you make a mistake, things blow up and people die.
Mm-hmm.
So there are situations where real-time data is mission critical. It's life critical. Even. Those are kind of systems I help customers with.
Absolutely.
So yeah, the right information, the right person, the right format at the right time. Then you have an agile organization.
And I think what happened is that there was a lot of great innovation in the larger, cloud tech companies, consumer-facing cloud tech companies like Facebook, social media type companies.
Mm-hmm.
And they would use very large amounts. They would use typically large amounts of data, and they didn't need to have like really perfect data to make potentially suggestions on ads or who you should potentially connect with, or this, that, or the other. So there was kind of wow, these sort of cool companies are doing stuff where it's not a strict, normalized, relational, well thought out data model. It's like, let's throw this in, let's throw that in, let's write code fast to do something with it. And there's certainly, in some cases, for simple problems, that's probably a fine approach.
Correct. So if you look at an organization, there's 3 levels of applications at the highest level. So the first level is the front office application, sales, marketing, customer experience. The next level is the core business applications. Those are the applications that are specific to that line of business. So when I went and worked with the largest airline in the world, their applications were very, very different than when I worked for an oil field service company. Very different. Core business, very different by industry. Then you have your back office application, ERP, HCM, payroll. Those are usually pretty common. So as you go through those applications, you can identify where the high value data is. So IT started 40 years ago with back office applications. So your financial data, most all the time, is the most valuable data. If you can't do your general ledger and produce your financial reports, you're in big trouble. So if you look at a lot of these high-tech companies who are talking about, especially some of the cloud vendors, they're talking about microservices and Agile and all this. Go look and see what they're running in their back office. It's a monolithic ERP system, and that's what they run their core business on. Mm-hmm. So it really depends upon what is the value of the information to determine what is the best fit information management technology. So you talk about Facebook or LinkedIn. If I send a message to somebody via LinkedIn and it gets lost, that's not a big deal. If I'm in financial services and I'm doing a bank transfer for $1 million and it gets lost, that's a big deal.
Yeah.
So it really depends on the value of the data. So that's one of the things we work on is how do we help our customers assess where is that valuable data, and then build an architecture accordingly.
Very cool. Well, let's use that to seg into ICAM. So I think that the fact you brought up, like the value of data, for example, is I believe part of that model. And so I want to just introduce how this is a big reason I brought Ron to the podcast. He has developed a way to think about information and its value to the business and how it's used and its scale, et cetera, et cetera. So both to the business and then also to the information architect. And the idea is then to have a process to think through based on the type of application and the business outcome you're looking for, how to make the best decision about the particular database to use. Yeah. So with that, Ron, do you want to just
let me give a little preview. So there's when it comes to information management, there's 3 decisions that people have to make. The first one is, what's the best fit information management technology? And that's what we're going to talk about today. That's what information characteristics architecture method, or ICAM, is about. What is the best fit information management technology? So once you choose the best fit information management.
Oh, I'm sorry. 1 second. Hold on. Continue, and I'll let my dog settle down. Go ahead.
The second decision is, what's the best platform? So based on the business requirements, what's the best platform to run that information management technology? And then the third decision, what is your best deployment option? Should I run this on premise? Should I run it in a cloud? Should I run it hybrid, multi-cloud? So 3 decisions. Best fit information management technology, we'll cover that. Best fit deployment platform, best fit deployment options, or this cloud hybrid. Okay, so this is my job. This screen, I love this screen because this is my job.
All right. Do you want to present? I think you have some slides. Did you want to? Oh, yeah. I'm sorry. I have to show them.
Yeah. All
right. Let me add to the stream.
There you go.
So yeah, there you go. So go right ahead.
This is my job. So I like to overlay that with a study that was done by 451 Research. Now, this is a couple years old. This was done in 2015, but I love this diagram. What this shows is over 270 information management technologies that were available at that time. And I don't think that number's changed. And it goes across 18 different categories. Okay. I find this to be quite overwhelming. So this is the problem that we set out to solve. You've got this plethora of options, relational, grid, cache, this thing, NoSQL and key value. You've got all these options. How do you determine what's the best fit information management technology? Mm-hmm. So that's what ICAM is about. It's a method for measuring the characteristics of information to determine the best fit information management technologies. What we're doing is we're solving the polyglot persistence puzzle. So polyglot meaning many, persistence meaning your data stores. So it's a big puzzle. How do we take all our requirements and put the pieces together and make really good decisions? So we came up with, after much research, and this was about 2.5 years of research that myself and some other people did. I had lots of people at Oracle look at this, and we have lots and lots of good information people at Oracle, as you can imagine. So we came up with 17 characteristics in this methodology. And I want to qualify this. This is a methodology. It is a checklist for people to go through to make sure they're making good decisions. It's not something you should dogmatically follow, like any methodology. Okay, so this is a methodology, a checklist. So the first set of characteristics are those that should be measured and determined by the business and the information owners, not by the information architects. Okay, the business should own the data. We, as information architects, DBAs, we're the stewards of the information. So we have some decisions to make, but the owners of the information should make some really important decisions. So the first characteristic is, what is the monetization value of the data? Are you taking this data and selling it? If so, this data is an asset. And there's people who are doing studies on, can we measure the value of your information asset, and should it go on your financial statement? That's a whole interesting discussion unto itself.
Oh, yeah.
The second one is the monetary value. So your transaction systems are tracking things and tracking things of value and tracking funds. So like I was talking about the bank transfer system, you have $1 million on a bank transfer, that's the monetary value expressed in that transaction or tracked in that transaction. The third one is probably the most difficult. What's the intrinsic value of this information? There's a lot of information, especially what we call reference information, that is very valuable, but it's hard to put a dollar amount on. The example here is your customer master file. If you lost all of your customers and all the backups of your customers, how would your business be able to run? If you lost all of your accounts receivable, how would you be able to run your data, run your organization?
Right.
So those first three are an attempt of information architects to put a value on the data and come up with even things like what's the cost of downtime?
Yeah. What's the extreme, that's right. You have a slide on like kind of ranges for this. So I look forward to seeing that.
Yeah. Okay, so number 4 is real-time consistency. This is one I get on my soapbox with. A developer should not determine if the database is going to have eventual consistency. There are a lot of systems where eventual consistency will cause business problems, sometimes severe business problems.
Yeah.
Like in a financial accounting system where you have debits and credits and have to balance, you never do eventual consistency. If you're doing an inventory management system where you're reserving inventory, you never do eventual consistency.
Right.
So that should be determined by the business.
Yeah, I agree. But like if I'm on Twitter and then I tweet something and something, I can't see it right away or people can't see it right away. I think, and then you need the extreme scale of somebody like Twitter. But to be honest, what's happened?
But again, that's low value data.
Yeah, what happened is there's something called the halo effect. I talked about this last week with my podcast guest, And the halo effect is like, you think the company's done something quite impressive, and many of these social media companies have accomplished a tremendous amount. But whether or not that relates to your business is a completely separate rational decision that needs, a structure like this, I think, to make the best decision.
Yes, I agree. Because, okay, 20 years ago, we didn't have Twitter. We didn't have a lot of this big data that we see.
Yeah.
Because it was just too expensive to keep. With the cost of storage going down, we can keep a lot of data that 20 years ago we couldn't keep, but it's still low value data. And how do you make sense of the data? How does it add value to your organizational decision-making process?
Right.
That's the question that has to be answered. Okay, number 5, time value. I said this before. This is the one characteristics that determine more of your architecture than any other characteristic, because you go range from everything like batch systems to real-time systems. Batch systems are very efficient. That's the best way to process data. Real-time systems, especially those that are highly available, 4 nines, 5 nines, 0 RPO, RTOs, those become very expensive systems, very complex systems. But that's how you get to a real-time, highly available system. Number 6 is security. Again, the end users know their data. They have to determine this data. What security regulations or requirements are put on the data. You also have regulatory requirements. I worked with a lot of industries like criminal justice, where they have to track things that go on and report it to the state and federal government. Oil and gas, a lot of regulations there too. So what kind of regulatory requirements on there? Because it may be low value data to the organization, but if you have to report it to the government and there's fines, then it becomes more high value data. And then the 8th one is availability. The end user should determine what the availability of the data is. And of course, the end user is going to say, I want all my data all the time. But then you have to apply a cost to that availability and show the end users that, yeah, you may not really need it all the time because that's pretty expensive. But still, the end user should tell you what the availability is. So those are the first 8 characteristics that you should be concerned about and measure, again. But it's the end users, owners of the data, that should tell you what the values are for these measures. Again, we'll get to the values in a little bit. Okay, so now we'll do the next group. These are the ones that the information architect should be concerned about. So number 9 is information complexity. There are some systems, little departmental systems, they'll have 15 or 20 tables or data structures. Those are very simple systems. When you get to your back office systems, like e-business suite, there are thousands and thousands of tables that are required to do that business. So some business processes are just very complex and require a lot of data structures. So
I think that's also another difference, right, with social media consumer apps versus business apps. And there was an Oracle sort of senior Oracle person I talked to about this, and they sort of emphasized that to me. It's like business applications are really complicated. Business logic is incredibly complicated. I mean, Twitter and Uber, et cetera, they're quite interesting applications, and they do things at an amazing scale, but they're relatively simple, to be honest. I mean, you have to do things at scale, you got to connect things, but bottom line is it's not at the same level of complexity.
Yeah,
so metrics are important.
In the data modeling, I can look at a Twitter and Uber and say, yeah, that's X number of tables, probably.
Yeah.
But again, go look at their back office systems and see what they're running.
Yeah.
Like their financial accounting systems. Okay, number 10, validity. It's a measure of the level of difficulty needed to validate the consistency and accuracy of the information. So a lot of times we get data that's just really messy. I've seen, I don't know how many end users that are notorious for going to the comments section or comment field, putting in very, very important data for one type of data. And then for another type of data, they put in the comments another type of really important information. So when you try and extract value out of the information, it becomes very difficult to validate that data. Number 11 is variety, the measure of the number of types of information. So rows, spatial, document, video. Just we need to be concerned about that because some information management technologies don't cover all data types. So we can eliminate some information management technologies. Veracity, this is a good one. The degree of noise or unmeaningful information included in an information set. This is very important when you're streaming data, especially if you're going off sensor data. Hopefully, 99.5% of your data is unmeaningful. You don't need it. You're only looking for those anomalies, which will be hopefully a small percentage of your data. So this is important, especially when we get into certain types of streaming and streaming analytics, how we're going to be able to filter the data out and not have to store everything coming from your sensors. 13 is everybody knows this one, volume. How much do we need to store and or archive? Velocity. Measure the rate of information being received, filtered, ingested, or retrieved. So we work with, at Oracle, we work with a lot of very high volume OLTP systems. So velocity is very important. Variability. This is a measure of whether the data is structured or unstructured. We hear a lot about, oh, this is unstructured data. We'll just go stick it in a Hadoop cluster and worry about getting it out later. And I'm going to get on my soapbox again here. Metadata. The question is, where's the metadata? So if you take a string of numbers and characters and letters and spaces, you really can't be 100% sure what that is without metadata. You can have a good idea, and people have run some really interesting machine learning to try and figure out what that data is. But without metadata, you don't know for 100% what that data really is.
Okay.
And one of the things we look at when information management systems and applications is, where's the best place to keep the metadata?
Okay.
So when I started many, many years ago, you were talking about before, mainframes, COBOL systems, we were writing against vSAN. The metadata was in the code.
Right.
You know, one of the first programs I wrote was a Fortran program in college. The metadata was in the code, which made the program very fast because you parse the data as you read it off the disk. It was very fast, but I'll give you an example. We were working, this was many, many years ago, on an integrated project management system for a big construction company, and we needed the mainframe accounting system to add 3 columns into the system so we could track costs. Well, that meant every flat file in that system was going to be changed, and every program that parsed that file system had to change and be retested.
Mm-hmm.
Add those 3 columns, they estimated it was going to cost $250,000 to do that. So mainframe is very fast. So the metadata is in the code, it's very fast, but change is very expensive over time.
Well, with a SQL, that's just an alter table, right? And you add the columns and...
That's the value of a relational database.
Yeah.
Metadata is stored in the database data dictionary. So you know the data is validated as it goes in. So you know what that data is. You can go query the database data dictionary and find out this is what's in that table. And if you build your data dictionary correctly, you put the comments in, you can actually have a glossary of terms built into your data dictionary, so it's very clear what that data is.
Right.
It adds a lot of value to the data, especially as you move the data through the information value lifecycle.
Right.
The third place you keep metadata is with the data. So XML and then JSON, you're actually bringing the metadata with the data, which, and when XML first came out, you say, oh, I have a table in a database, you want to extract it and put it into XML, we'll increase the size of it by 3 times. Mm-hmm. Because that's how much the metadata was going to add to the volume of the table. Mm-hmm. We've improved that over time and have different standards now. And so JSON, it's not that bad. But still, you have the metadata comes with the data, which means as you pull the data in, you still have to read the metadata and parse it.
Okay.
So those are the pluses, and there are pluses and minuses of each one of those. Mm-hmm. And building an application and deciding on information management technology, that's one of the questions you should answer. Where's the best place to put the metadata? Which goes to, again, number 15, variability, structured or unstructured. 16, data sparsity. This is a measure we use in data warehouses a lot, which is how complete is the data at any point in time. We usually, and this is a measure we use for OLAP, for cubes, and designing cubes specifically. And then 17 is geographic dispersion. So a measure of the geographic areas in which the information will be retained or queried. Okay, so it's a high-level overview of the 17 characteristics. The value of a good information architect is understanding the relationships between these characteristics. Mm-hmm. I'll give you a very simple example. So let's say that we have a low value, we're selling widgets. So it's fairly low value data, $5 widgets. But it needs to be up all the time because it's on the web. we have fairly high velocity, and we're selling in different points around the continent. So we have a certain amount of geographic dispersion. That would be a good use case for a sharded database.
Mm-hmm.
Simple transactions, highly available, geographic dispersion, a sharded database. Okay, so that's the value of information architecture. Understanding what these characteristics are, how they should be measured, but more importantly, what are the relationships between them?
Mm-hmm.
So what we've done is, this is an example, is we've set some ranges. So, and these ranges we found out are going to differ by the business and the industry.
Mm-hmm.
Like if you're in pharmaceuticals, we talk about volume. If you're in pharmaceuticals, multiple petabytes is pretty much the norm. But if you go to a manufacturing company like a heavy equipment, 500 terabytes might be the largest database. So it's going to vary depending upon the industry. But you, for your organization, can come up with some basic ranges. So, and you give a high and low value. Some people do 1 to 5. I prefer to do 1 to 10 because you get more granularity. So it's just a matter of going through it and setting what do these ranges mean, and what do they mean to the business? Like
when you say variety, for example, so related to what it means to the business. So let's just look at a variety. So all the data number of VARCHAR, or could be up to 10 data types. I see. Okay. So when you say data types, you mean like spatial and graph, etc., or what kind of what do we mean?
Video, pictures, lots of different types of data. So as an information architect, I have to be aware of that because I'm going to design my database based on those types of data.
Yeah.
Okay. But more importantly, things like security.
Yeah.
If the data is lost, if ransomware, you lose the data or it's stolen, if it's low value data, well, yeah, it may cost you $1,000 or $100,000. But if it's very valuable data and it falls under things like HIPAA, then it's going to cost you potentially a lot of money. I actually worked with a company where ransomware cost them over $1 billion. Billion with a B. So security is top of mind for that company, right?
Yeah, what I've found it interesting. Most of the companies that I've talked to, they just seem to underestimate the high range significantly. And I mean, even if you look at their peers, typically their peers, if it's a sizable company or in a regulated industry, I mean, the fines, 10 million is just getting started. I mean, some of these fines are 10 million a month, 10 million a month. I mean, and if 10% of the companies in your industry or 15% have been hit by a security breach, and the average size of the cost of the breach is 100 million, then the cost, essentially your expected value of that is the probability, call it 50% times 100 million, so 15 million. So strengthening the security with a better information architecture is a $15 million improvement.
Correct, because coming up with those ranges then gives, and then measuring the type of information against those ranges then gives the information architect the justification for going and really for spending the money and the time to make sure that data is locked down.
Right.
It's a highly secure system.
Yes.
Okay, so here's an example. So I put the measures on the left side with the characteristics, and then put it onto a radar chart. So this is, characteristics are, it's pretty good geographic dispersion, a lot of pretty high data disparity, a lot of variability, velocity, volume's high, velocity,
sure,
these are all high. But this is low value data, so the time value is not important. It's not secure. It doesn't fall under any regulatory compliance. It doesn't really need to be available. Complexity is pretty. So this is a pretty standard pattern for data.
Yeah.
This scenario would be, we're pulling in social media and storing it so we can do analysis on it. Here's another example. We're doing a storefront. We're selling widgets again. The example I used before. So geographic dispersion is high. Data sparsity is very low. Variability, okay. Velocity, it's a little bit high. If we sell a lot, we're going to have decent volume. Veracity is low. Variety, we have some pictures. Validity is very low. Complexity is low, but it needs to be up because we're selling things. 724 on the web. very little regulatory compliance, very little security. Time value is important, though, especially when you're selling widgets, and it's an inventory system. So we need to have real-time inventory system. Real-time consistency, yeah, you can read those. So this is a typical NoSQL pattern, where I can shard it, I can get my performance that I need, I can get my availability.
Why is real-time consistency not important in something like that?
That's one of those that it depends upon what you're selling, what you're doing.
Okay.
If your inventory systems are local to where you've sharded to, you know what sharding is? It's individual databases with a layer on, effectively a layer on top.
Okay.
To coordinate the databases. My inventory system is right there next to my sharded database that I'm selling from. Then eventual consistency between the different inventory systems is not that important because they're all standalone. So it just depends. If you had one inventory system, then real-time consistency would go way, way up.
Okay. Cool.
But this is a NoSQL pattern.
Yeah.
Let's go to supply chain.
Okay.
So supply chain, especially if you're building very expensive equipment, that you get a completely different pattern. So monetary, you don't really, some high, medium high monetary. Intrinsic value is high, like your product master file. You need real-time consistency in supply chain. Time value is very, very important.
Mm-hmm.
Security may not be that great. Regulatory compliance depends on your industry. That might be very high, especially if you have a lot of waste, like chemical waste in your processes.
Mm-hmm.
Availability is important, and usually these are pretty complex systems. But all those other measures are pretty slow or pretty low.
It's like the exact inverse, almost the inverse of the storefront, the NoSQL. Yeah.
Yeah. So this is a pretty typical relational database pattern.
Mm-hmm.
So now let's take that supply chain system. Let's put a bunch of sensors on our supply chain. So now we're going to track our raw products coming in. We're going to track what happens on the shop floor, and we're going to track finished products as they go out. So then our velocity, our volume, and potentially our velocity, they go up quite a bit. So this is the real value of ICAM. We now have a non-standard pattern. So this points to, do we want to do NoSQL here? No, there's some characteristics that don't fit NoSQL.
Mm-hmm.
Do we want to do relational? Yeah, we might be able to do that. And I'll do a quick little Oracle plug. So I could do this on Exadata, because Exadata has a throughput for the sensors. And the latest version of our database has an IoT capability, so we can stream data directly into the database. But other databases, you might consider doing a single model platform where you do the sensor data into a NoSQL database, but the other data you go ahead and keep in a relational database.
Mm-hmm.
It's going to make your system more complex because you now have two databases, but that might be an option.
Cool. Yeah, I see how it's essentially the supply chain, but then, like you said, you up the velocity, volume, and but also the need for veracity.
Because of all the sensors, yeah.
Right.
The sensors, you have a lot of noise in the data coming in, so the velocity can be pretty high.
Right. So to your point, I don't know. I mean, it feels like the industry, there was this brouhaha, basically it was like, well, we need NoSQL to scale and to really handle something like big data, and relational is too constricting. But then everybody over time, over the next decade, basically put back SQL or some kind of faux SQL back into their APIs and the way people interacted with their big data store, or NoSQL data store. And then eventually just all the things, the hard problem SQL solved, crept back in. And so in the meantime, Oracle and frankly other companies that build great relational databases, we think ours is the greatest, but there's other awesome ones out there. But the relational folks added different data types, add the ability to handle JSON. SQL itself is actually not relational. Relational is part of SQL, but since about 90, I think it's the standard was upgraded in 99 to add objects. Basically, it's not, SQL isn't necessarily relational. It can be, but it doesn't have to be. So
relational becomes a subset of the SQL programming language, especially if you start putting in spatial and graph like we have in the Oracle database.
Right. So I think you have a couple more of these. Let's keep going through, and then I had a couple questions.
No, those are the main patterns that I show. But next is, here's all your options.
Right.
So on the 451, I took their 18 categories. I distilled it down to 14 categories.
Okay.
So each one of these types of information management technologies, they have use cases. There are specific times when they make sense. They make the most sense to use. So, and again, that's the challenge of an information architect,
But
is not to go to the shiny penny, the latest fad, but to have a systematic methodology for determining, based on the characters of the information, what is the best fit information management technology.
right, but there's also a back. So let's go back to your point about there's sort of enterprise architects that see the end-to-end, the big picture, but you also have infrastructure architects, data information architects, and application architects.
Correct.
And one of the interactions I had with an Oracle customer, big Oracle customer about a year ago, was really on this issue. And in fact, what you're showing here, this particular company, which is a $40 billion a year type of company, had literally a different technology for each of these, 14 categories. And they had chosen a specific vendor. And the idea was, well, there's a best of breed product in each of these categories. And frankly, there wasn't much of an architecture. It was really more, frankly, they were repeating whatever the vendors had told them. And what I appealed to the VP, the infrastructure architects and the people running infrastructure, and said, how are you actually going to run, a dozen different data stores and have consistency across how you do backup and replication, availability and performance management and security and upgrades and patching and on and on and on? You're going to do that for 15 different data stores. So what's the answer here? Do you really go with something that's pure best of breed in each approach? Or do you try to find something that converges a lot of this functionality into an operational database that really has, let's call it, it's wideband, right? So a wideband database is going to be able to cover really all of the dimensions you've described. Now, there's still the question of cost, and maybe your problem's simple enough. And I think that's the beauty of ICAM, is you can start making these choices. But, what are your thoughts there?
Well, I'll use the canned answer we have in our industry. It depends. That's what makes a job of enterprise architect and information architect so interesting.
Mm-hmm.
I cannot give you here, I'll tell you this story. So we developed ICAM, and one of the managers at Oracle said, hey, this is great. Let's go look at these 17 characteristics and these 14 possible outcomes. And let's build a machine learning algorithm so we can just plug in some numbers and it'll spit out an answer. Well, we gave this to one of our data scientist gurus, and he looked at it and he went, let me see, okay, 17 variables coming in with 14 possible outcomes. And these outcomes, 14 outcomes, are not mutually exclusive. So the outcomes are really 14 factorial, which is a really, really big number.
Absolutely.
He looked at it and went, no, there's no machine learning algorithm that can take on the complexity of this problem.
Yeah.
He basically threw up his hands and said, no. So that's leading to why us architects will never be machine learned out of a job.
No. No.
Because it takes a lot of experience and a lot of knowledge to be able to go in and make really good decisions based on these characteristics. But that is the reason why we developed ICAM, was to give our customers a methodology, a way of systematically looking at the problems and making good decisions.
Yeah.
And I've had several organizations look at this and go, some look at this and go, wow, this is really complicated. Others look at it and go, this is great. This is what we've been looking for. I had one very large financial organization, the DBA team, said, this is great. The developers keep buying the latest shiny penny fad, silver bullet, developing something and throwing it over the fence, and we have to manage it. This gave them a methodology so that they could push back and say, what's really the requirements? Let's go with the requirements, and then we'll jointly make a good decision.
Right. Yep. Absolutely. Well, it's interesting because to your point, this very large $40 billion company eventually actually simplified and bought. Oracle's argument is, hey, you can do almost all of these in a single database called the Oracle database. And then you have a single way to do backup and replication and availability. And you have, You can scale down, you can scale up massively, and you can do it with a team. You can train your team on this one technology, and away you go. Now, it's interesting. There's a little bit of a contrast with this. We acquired a company that did. It was basically a cloud company, and it had an API, and you interacted with this API to, I'm not going to mention the specific product, but basically they had a very, very specific product that was very popular, like billions of accesses a day or trillions through this API. And it originally had something like a NoSQL database, or maybe it was a PostSQL database. And then we converted them to Oracle. There are other, they didn't have to solve an enterprise problem. They just had a single application. And their other database, it turns out it was nowhere near as good as Oracle. So the bottom line is Oracle outperformed it pretty much in every dimension. But it is true. There's no question. When I talked to some of the developers, because I was building some content around that, there's no question that there is like there has been a baseline of expertise you need to run Oracle well. And Oracle's starting to address that with autonomous, so that a lot of the management becomes automated away. But at these sort of extreme scales, like, which is in your model, it's the volume and the velocity. If you're at that extreme velocity and volume, then you really have to think about it. And it may be that like a one-off database that your developers really like, and that you don't have to, you're only running, you're a single company, that's the only thing you run, and it works. Might be something to consider.
Let me make a point. So a lot of people say, Oracle database is too complex. The Oracle database is complex from one dimension because it has so many knobs you can tune.
Correct. If
you go to a database and it only has 3 knobs where you can tune, then chances are you're going to hit a performance wall pretty quickly.
Yeah.
That's why a lot of people do like the Oracle database. It's very, very tunable. You can tweak it all sorts of different ways to get the maximum performance out of it, which is why so many companies use it for their mission critical, high volume, high secure systems. It's very tunable, very, very tunable.
Yeah, and I mean, fundamentally, enterprise, again, I think a lot of times what happens is we come at this with our own set of like preconceived notions about what an application should be, or what, to your point, information value. What I love about this is it tries to pull you out of that bias towards, well, this is the way I've done it in the past, or I work for Facebook and Twitter, and this is how I think about data. Well, that's appropriate for Facebook and Twitter, and it might apply to a new problem, but it might not. Yes. There might have been things that were thrown out by the NoSQL that really were still necessary. And I think that's kind of how things ended up evolving. And some of the original SQL pioneers, including, I'm trying to remember a very sharp-tongued fellow, his name will come to me, but he wrote some very pointed criticisms of here's what you lose when you take SQL out and you throw normalization out the window.
Oh yeah.
Don't consider it important.
Okay, yeah. I'm going to get back in my soapbox here.
Yeah, that's right.
I came out of college knowing first, second, third, voice cod, fourth, fifth, domain key normal forms.
Yeah.
What all of that meant. I have been asking a lot of people that were hiring right out of college, especially CS majors, they have no idea what data normalization is. So third normal form eliminates insert, update, delete anomalies. They don't know what that means. What that means is you don't have to write as much code. If you get all the way to fifth normal form where you're eliminating join anomalies, you've even reduced the amount of code needed to maintain that data much more. So if you want to be agile, you should normalize your data because it doesn't take as much code to build the application. Yeah, this generation seems to have lost that knowledge, that wisdom.
I think there's no question. And to be honest, again, that's why I think a process and a model to think about this is important, rather than, there's a very cool company called Netflix built something very cool with microservices, which they did. But what if you're not Netflix and you're not in the video streaming business at planetary scale, which, let's see, that's pretty much almost every single company on the planet, other than maybe Amazon's Prime Video and a couple of others. you really need something like ICAM, so you used to sit back and think about this. But back to your point, I mean, yeah, I never quite understood. It's like if you don't normalize your data, there's a lot of very serious downstream consequences, to that. If you're able to come up with a normalized data model, you can basically join things in a way that makes the data reuse, it's data reuse, a lot less code, and yet you can still essentially add columns in a way that's fairly transparent to your existing code. So yeah, I think people, it's interesting.
Okay, let me expand on that. I'm going to give you a term, a timeless data model. Okay, I've created in my career timeless data models where those data models were used 15, even 17 years from the time we put the system in production.
That's amazing.
Okay, so what does timeless mean? It means you spent the time to design the data structures so they mimic the real world.
Yeah.
That's what we can do in a relational database.
Mm-hmm.
We can mimic the real world in our data structures. If we do that properly, then the realization in the real world, things don't radically change. Things become additive. So if I do my data modeling correctly, identify my entities, my things of significance, if I identify my primary keys, foreign keys, I do that right, then a change is usually not, well, I got the primary key wrong, I have to decompose it, I have to break it into two tables. That's a major rewrite of your application. A change is, we're going to change the business. We need to add something to the data model. We're just adding. We're not actually making physical changes. So I don't know if I'm clear on that, but that's what
it's very clear.
It mimics you do the analysis, it mimics the real world. So as you add things to your business, you don't have to change that data model. You add things to the data model.
That's amazing. And again, it speaks to, to your point, if you're able to reuse that data model and incrementally evolve it, and I think you're seeing that, like basically pretty much, not to get onto not to get too like specific to Oracle, but nonetheless, all of the vendors that had originally said SQL was no longer relevant have pretty much been frantically trying to reinvent things like joins, things like some form of normalization. And I had one of my more interesting guests he was about six or 7 months ago. His name was Ron Beckerman, and he was a CTO at Cherry, which is a cloud analytics firm that focuses on commercial real estate. And do you know what his number one problem was? The number one thing he put most of his resources on was normalization. So he actually used machine learning and AI so that he could figure out which corporate entities owned which buildings. And the problem is you might have thousands of ways to describe JP Morgan Bank, right? It turns out there's just an insane number of ways. So he put a lot of his machine learning stuff into just simply that problem. And I think he's definitely an information architect, but he's again that systems end-to-end viewpoint. What's the business outcome? And for him, the most important thing for him to make that business successful is to make the data as correct as possible. Because if you think about it, it's kind of like Zillow, right? If you go into Zillow and it doesn't have your home properly described, doesn't have the square feet right, it doesn't have the location right, it doesn't have the features right, guess what? You think Zillow is pretty crappy. And so Sherry has the same problem. You have to have really good data. So so I think personally, that again, back to the model, I think it allows you to create a framework to think about your choices and where they lead you. So and that can really help with these human biases we all have. Like we have a preference. You and I, let's face it, we understand Oracle. We've deployed it. We've sold it. We've seen it perform very well in production. So we both have a general bias towards, hey, that's the right answer. And we don't have time to necessarily deeply understand all the other alternative technologies, but at least with something like ICAM, it forces you to get outside the box and start thinking about the problem in the abstract, and then I think that's powerful.
Some people have used it very, very successfully. And it's helped them make very good decisions.
Cool. So with that, do you have any final thoughts or comments? We're pretty much running a little bit over, but this has been fantastic. I really appreciate you taking the time. Any final thoughts on just enterprise architecture or these types of models for good decision making?
So if you want to have a whole nother discussion, another hour discussion, we're working in our EA Masterclass developing skills around what think like an architect means. So I've written a white paper on LinkedIn where I talk about different types of thinking, different ways of thinking, and how a successful enterprise architect should think to be able to going back to the very first slide I showed, on how to think to be able to solve very large, complex problems for large multinational companies.
That sounds like a great topic. So I'll tell you what, I'll make you a deal. If you can do this, let me put up my banner here. Let me get the banner up. If you can, okay, this is current banner. Our next podcast is, oops, I screwed that up. I apologize. It should say June 16th. Can you join us next week, same time?
I would love to, but I'm going to be 35 miles offshore Louisiana fishing.
Yeah, I know. You're always off fishing. Do you ever actually work? No, just kidding. I know you do. Let's schedule it for later in June then, so we can do a part 2 on this. And yeah, that sounds great. So let's continue with, again, this discussion of these sort of senior roles like enterprise architect that have to think about the big picture, how to help you make better decisions, especially in the context of these really large multinational companies that at least you and I get to deal with every day. So anyway, again, Ron, thank you very much. I really appreciate it.
Thank you for having me on. It's my pleasure.
Yep. And we'll talk to you in a couple of weeks.
Very good. Thanks.
All right. Take care. Yep. Thanks again. Bye now.